Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for this video, we will look at a question from Form 4 Chapter 1 Functions. So before we begin to discuss this question, you all can have a look and try it by yourself first. So what we can highlight in this question is we are given a function h of x and its reflection k using the straight line y equals to x, which is shown in this diagram. So here we have learned a fact in inverse functions, which is, so meaning this k of x is actually h inverse of x. Okay, so this is one of the concepts for inverse function. So when a function is reflected on the y equals to x line, or using y equals to x as the mirror, the image it produces will be the inverse. So going into question A, we are given h of x, x squared plus 3, and we need to find function k. So here meaning we need to find the inverse function, since k is the h inverse. So here, to transform an original function to an inverse function, we need to use the 3 steps which we have gone through in the previous videos. So I'll put one of the links in this video. So we let the function given as y, and we move the h to the other side, so it will be h inverse y equals to x. So our step number 1 would be to use our first step. So h of x equals to x squared plus 3, we need to change our h of x to y. Second step, let x as the subject. So meaning our x need to be on the left side. And lastly, we need to use the second let. So our x would become h inverse of y. And don't forget, since our function here, the object is x, so we need to change our object as well to become x. And remember, don't leave this as h inverse of x because we are finding k now. So we need to change it to k. So there's another interesting thing if you notice here. When I move the square to the other side, actually it should be x equals to plus minus square root y minus 3. There will be 2 cases, but here we just consider the positive case, because if you look at the graph here, this graph, all the values of y, which is here, are all positive. So we don't have to include the negative case. So here we just consider the positive case. Alright, so part B, hence, show that hk equals to khx. So here means that for this part, if I apply x into k, so k is our h inverse, and let's say it produces an image of y. So if I use back the same function, which is the original version, I will go back from y back to x, since it's the same function. So I would get back my original object. Same goes to this one. If I apply h first, it will produce y, let's say, and I use the inverse function, so I will go back to the same object. So my answer here, I'm expecting to have x, because my object is x, so the result I will be getting is the object. Right, so let's try out first. So hkx, so don't forget, for functions we need to look at the inside ones first. So we're just going to substitute kx's function, which is square root x minus 3, and we're going to use h. So the h function is, okay, so now I just need to change the x, since my new object is square root x minus 3. So if I just simplify this, square root and square, and minus 3 plus 3, it will get x. Okay, so this is expected. So if I use the other way around, so as you see, 3 can cancel off, and our square root and square can cross out each other. So the final result will also be x. Okay, so we have shown that these two functions, the result is the same, which is x. So let's go to part C and to highlight some important parts. So here it says that for point A and point B, there are the closest points from h of x and k of x to this line. So now we are trying to find the distance from A to B. And A, they've given us the coordinates. So the question now is, what is the coordinates for B? So since k of x is the reflected image of h, so everything will be reflected, including the coordinates. So let's say the coordinates for A is 1 over 2, 13 over 4. So this would be reflected as well, which is inverted as well. From x coordinate, it will become the y coordinate will become the x coordinate. So B coordinate will be 13 over 4, 1 over 2. So everything is reversed. So here, in order to find our distance AB, we can use the distance formula, which is x1 minus x2 square plus y1 minus y2 square. And the coordinates are, so here it will be 3.889 units. And we have completed this question. So the take home point for this video would be, for grass reflected under the line y equals to x, this would be their inverse. So we can see this as an example in here. So h of x reflected onto this line, k of x would be the inverse of h. So if you're interested in this video's answer scheme, you can click the link in the video description, and you feel this is beneficial to you, please like, subscribe, and share it to your friends and classmates. So I'll see you all very soon in the next video. Thank you.